lecture, I am going to start the new topic logic system and logic gates. So let us discuss first what is logic system. What is meant by logic system? So in digital electronics, before I am going to have discussion on logic gates, now I am going to tell about what is logic system. The system in which various logic levels are defined is nothing but logic system. Okay, the system in which various logic levels are defined is nothing but logic system. So basically in digital we have two types of logic system. The first one is logic 0 and the second one we have logic 1. In digital these are the main logics that we are going to use. So the basic definition I told, the system at which various logic levels are defined. So here we have logic 0 and logic 1. These are the two levels we are having. So this logic system is again classified into two types. The first type of logic system we have positive level logic system. Okay, and second type of logic system we have negative level logic system. Then what is meant by positive level logic system? So in the positive level logic system, you can observe the presence of 1 is greater than the presence of 0. The presence of logic 1 is greater than the presence of logic 0. So that means here 0 is considered as low level and 1 is considered as high level. So positive level logic system. In this manner, what is meant by negative level logic system? Just quite opposite. That means 0 is considered as high level here. Okay, and 1 is considered as low level. Just reverse way of writing to this. Okay, so this is nothing but the presence of 0 is more or greater than the presence of logic 1, which is nothing but negative level logic system. So I given two clear-cut definitions here. The logic system is classified into two types. One is positive level logic system, another one is negative level logic system. In the positive level logic system, I said that the presence of logic 1 is greater. That means 0 is low level, 1 is high level. Whereas quite reverse and opposite to that, negative level logic system. In the negative level logic system, 0 is considered as high, 1 is considered as low. That means presence of 0 is greater than presence of 1. Based on this, we have some notes. Positive level AND gate is equal to negative level OR gate. Positive level OR gate is equal to negative level AND gate. So I am going to prove this. And positive level NAND is equal to negative level NOR. Positive level NOR is equal to negative level NAND. Positive level XOR gate is equal to negative level XNOR. Positive level XNOR gate is equal to negative level XOR and NOT remains same. Okay, now let's prove one thing here. Okay, before I am going to discuss the logic gates, let's prove one thing here. The basic thing we already know, the basic operations like AND operation and OR operation. So I am going to prove the first one. Positive level AND is equal to negative level OR. So here positive level means I said 0 equal to low, 1 equal to high. That we know. Negative level means 0 is high, 1 is low. This is also we know. Now you can observe here, let me draw AND truth table. A, B, A and B, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, right, this one. So let us try to write into positive level logic system manner. 0 means here low, so low, low, which giving the output as low, low, high, which giving the output as low, high, low, which giving the output as low, high and high, which is giving the output as high, right? So this is the positive level end statement, which equal to what I said, negative level OR. First let me write OR gate. OR gate means 0, 0, so A, R, B, 0, 1, 1, 0, 1, 1. So 0, 1, 1, 1. So this is OR. So in the OR gate, I said you clearly that 0 is high, 1 is low. In that manner you can write high, 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 low, low, high, low, low. 0, 1 means what? Low, low, low. Now you can see these two tables. Whenever 2 highs, the output is high. Whenever 2 highs, the output is high. Rest of the cases, the output is low. Okay, in this manner, I can able to prove that positive level AND is equal to negative level OR. Okay, so based on the logic system, I given some statements. Try to note down all these statements. Now let us discuss what are all logic gates. So now let us discuss what are all logic gates and how to study the logic gates. Each and every topic now we will discuss in a depth manner. Okay, let us discuss what are all logic gates. So logic gates are basic building block of any combinational and sequential circuits. A gate may accept 1 input or 2 input, 3 input or n number of inputs, but it will produces only one output. So this is the basic introduction about logic gates. And now the logic gates are classified into 3 types. The first type of the logic gates we have is basic gates. Second type of the logic gates that we have is universal gates. Third type of the logic gates that we have some special gates. Sometimes arithmetical operation also we are going to use this. So let us see what are basic gates, what are universal gates and what are special gates. So the basic gates are AND, OR and NOT. NOT is also called as inverter. Okay. So why these gates are called as basic gates, I will tell you. First let you know people what are the various classification of gates. Okay, let us know what are the various classification of gates. And the universal gates we have NAND gate and NOR gate. So these two are the universal gates. So I will tell you why these two gates are called as universal gates. And the next special gates we have is exclusive OR and exclusive NOR gate, which are also called as odd gate and even gate, inequality gate and equality gate. Likewise, various names are given. I am going to explain in depth whenever we are discussing the particular gate. So firstly, let's have some idea on this. Why AND, OR, NOT are called as basic gates? So generally AND, OR, NOT operations are the basic Boolean functions. In that we are going to use these gates, right? So these gates will do the basic functions. Hence these are called as basic gates. Okay. And next NAND and NOR. Why these gates are called as universal gates? Because by using NAND alone we can able to construct remaining all other gates. By using NOR alone we can able to construct remaining all other gates. Hence NAND and NOR gates are called as universal gates. Then why XOR and XNOR are called as special gates? Because exclusive OR and exclusive NOR gates are used in some special operations, like you can take half adder sum, full adder sum, magnitude comparator. We are going to use all these kinds. XNOR we are going to use. And XOR will be used in half adder sum, full adder sum. So at such cases, we are going to have some special operations. In that we are going to use these gates. Hence these gates are called as special gates. Now let us try to study all these gates. Before that, let me give you the IC numbers. These all gates are constructed by using transistor logic family. Okay, and the TTL IC numbers, let me give you first. So the NAND IC number is 7400. So it is constructed, the IC number is 74XX. This is the series of transistor logic. And NOR gate we have 7402 is the NOR gate, transistor logic. NOT gate is 7404 and AND gate is 7408. OR gate is 7432 and finally XOR gate is 7486, 74266. These all are the IC numbers. Okay, on IC we get some numbers, right? These are constructed with TTL family, transistor logic family. Hence I am giving these all numbers. So note down this classification first. All of you note down this classification. Now we will enter into one by one logic gate. Let me explain you one by one. So first I am trying to explain you the basic gates, then after universal gates, then after special gates which are XOR and XNOR. These are very important. If you are preparing, entire digital electronics contains further topics whatever comes like combinational circuits and sequential circuits. Via these gates only we are going to construct anything. Okay, now let us begin. The first gate under the classification of basic gates, the first gate is AND gate. It is represented with A and B or A intersection B. Okay, so two input gates I am taking. First let me draw the logic symbol. So the logic symbol of AND gate, which is of two input, here I am representing. This is the logic symbol. A, B are the inputs and the output we have Y is equal to A and B. This is the output. A, B are the inputs and the output is Y is equal to A and B. Now let us write the truth table. Truth table will give the relation between input variable and output variable. So the input variables are A, B and the output variable Y is equal to A and B. So the possible combinations here are 0, 0, 0, 1, 1, 0, 1 and 1. So these four are the possible combinations. Now you can listen me. I am giving one statement that if A and B come to the class, I will teach the class. So I have two students. A is one student name, B is another student name. I am giving one statement that if A and B come to the class, then only I will teach the class. So first day A is absent and B is absent. So I don't take the class. Second day A is absent but B is present. Then also I don't take the class. Third day A is present but B is absent. I said that A and B both will come to the class, then only I will take the class. So then also I don't take the class. And the final day A and B both came, then I am going to take the class. Simply saying that A into B, 0 into 0, 0 into 1, 1 into 0, 1 into 1. So we are going to get this as truth table. So this is the truth table of AND gate. Now I am going to draw the Venn diagram model. Intersection means this is A this is B. So common portion. So this is the diagram of Venn diagram of AND gate. Okay, Venn diagram for AND gate. Now let us draw the switching model, switching network, switch model simply. Okay, so how to draw the switch model is the switches are connected in series. Okay, here VCC, switch A, switch B. So this is the switch model for AND gate. Okay, logic symbol, truth table, Venn diagram model, switch model. Now let us give two more models, which is diode model and transistor model. See here in switch model, when both are high, then only output will be 1. High means what? Short, short. When both are short, okay, short circuit, then bulb will be glow. At the output side you can keep a bulb. Okay, so now let us discuss the diode model. So let me draw the diagram first. VCC and ground, and let us take the output here. AB output. This is A, this is B, this is diode 1, this is diode 2. So in examination, you don't just concentrate on the analysis. He will give this diagram directly. The figure shown below is act as a dash. Options: AND gate, OR gate, NAND gate, NOR gate. Don't focus on resistor, diode and all. Just diodes are facing towards where? Just you can observe that point. So here you can see A, B, 0, 0, 0, 1, 1, 0, 1, 1. Whenever both are 1, then only 1, otherwise it is 0. Both are, if any one of the input is 0, you can observe here analysis. If any one of the input is 0 means, for example, if this is 0. Okay, so always supply flows from high to low, right? High to low. And the work of ground or earthing will always absorbs the supply. Okay, will always try to takes the supply. Remember these 2 points. Whenever it is grounded 0, always I said that supply flows from high to low. That means supply flows like this. This ground will catch. If it is 0, this ground is going to catch. If both are 0, both grounds are going to take. If both are high, means this is open and this is also open. When both are open, the output will appear here. Okay, because here there is no path. To travel here, there is no path. Whenever both are high, so that will be collected at output, VCC will be collected at output, that is what I written it as 1. So this analysis is not required for the competitive exam. For the competitive exam, the figure he will give, the figure shown below is act as dash. Your answer is AND gate. And now let us discuss about the transistor model of AND gate. You need to study each and every point in depth. Okay, so now let us study transistor model of which gate? AND gate. So let us study the transistor model. So the transistors are connected in series. So this is A, this is B, this is VCC, and collect the output here. Okay, so whatever you can keep resistors or you can directly give here. So observe here, when A, B, don't concentrate on the diagrams, concentrate on the logic and the symbols. He will give just the figure directly in the examination. He will ask you that the figure shown below is act as AND gate. So if any one of the input is 0, if it is 0, this transistor will be off. Off means open circuit and Open circuited means VCC will never flow like this. If it is 0, up to VCC will flow up to here, here it is open circuited. So if any one is 0, if both are zeros, both are open circuited. There is no path, hence output is 0. If both are ones means this one is shorted and this one is shorted, then output will be catched here. So output is 1. So this is the transistor model of AND gate. So far what I discussed, the first one I discussed is logic symbol of AND gate. Second one that I discussed is truth table of AND gate. And next I discussed that TTL logic, that means IC number of AND gate. Then I discussed that Venn diagram model of AND gate. Then I discussed that switching network or switch model of AND gate. Then I discussed that diode model of AND gate. Then I discussed that transistor model of AND gate. Okay, don't focus on the diagrams, the shapes and the scenario, how they are connecting either series or parallel. Okay, in that manner you have to check. So in this way, in depth we are going to discuss about AND gate. As it is a basic gate, this gate is going to useful for us in basic operations. Okay, and next, coming to the next gate, let us discuss OR gate. Okay, this OR gate is also called as basic gate. Okay, because it is going to do the basic operations. In Boolean algebra, we seen the basic operator as OR operator. And now the logic symbol for OR is like this. A, B are the inputs. So output Y is equal to A, R, B. Now the truth table. So the truth table, how I am going to draw? A, B are the inputs. Y is equal to A, R, B. Okay, here it is written as A union B or A or B. Right, 0 0 0 1 1 0 1 1. Now I am changing my statement that if A or B come to the class, I will take the class. Previously I said that if A and B come to the class, then only I will take the class. Hence 1 1 only, last day only students came. Now I am changing my statement. If A or B come to the class, I will take the class. First day students will be absent. Second day A absent, B came, I will take the class, because I said a statement that if A or B come to the class, then I will take the class. Third day A only came, I will take the class. Fourth day both of them came, then also I will take the class. This is what 0 plus 0, 0 plus 1, 1 plus 0, 1 plus 1. So note down this truth table of OR gate. Truth table of OR gate. Next I am going to draw the Venn diagram. So A or B means both A and B. So this is the Venn diagram of OR gate. So switches, previously switches are connected series, now the switches should be connected in parallel. Okay, this is the switch model. And next, coming to the diode model. So let us discuss the diode model. Previously diodes are facing towards this, now the diodes are facing towards this. Okay, so the diode model. If you want, you can check A, B, A, R, B, 0, 0, 0, 1, 1, 0, 1, 1. So 0, 1, 1, 1. If anything is 1, the output is 1. If anything is 1, that means if it is high, this is short. Okay, if any one is 1, this is short. If both are 1, towards both things, the supply will flow. So this is the diode model. Previously diodes are facing this side and now the diodes are facing towards this side. Now transistor model, coming to the transistor model, previously how the transistors are connected? Series. Now how the transistors will be connected in parallel. So same thing. So don't worry about the diagrams, just I am drawing, just know the structures and shapes. Y is equal to A R B. So if it is 1, with the help of this we are getting output. If it is 1, with the help of this we are getting the output. If both are 1s, with the help of both we are getting the output. If both are zeros, both are open. Open circuit means there is no flow. No flow means output remains 0. Okay, note down this. Note down this. So here you understood one logic. Into means end things are series. Plus means R things are parallel. This is the logic we came across here. Okay, note down this. Now we'll discuss the next gate. Which is NOT gate. So NOT gate is also called as inverter. So what is meant by NOT gate? NOT gate means output is not same as input. Okay, that means you can observe here, this is the logic symbol. If A is the input, A bar is the output. So Y is equal to A is the input, Y is equal to A bar is the output. So let me draw the truth table. 0 for 1, 1 for 0. So this is the NOT gate. So here switching model, let me represent. The switch is connected like this. Okay, the switch is connected like this. And coming to, there is no diode model, coming to transistor model. You might studied one experiment that transistor act as a switch. So if you give the input as 0, 0 means this transistor is off, off means output will be taken by this. VCC is taken by output. If it is 1, transistor is short circuited, so output is catched by the ground. So 0 for 1, 1 for 0. The inversion is going to take place here. So this is about the inverter or NOT gate. So till now we studied the basic gates like AND gate, OR gate and NOT gate. Now we are going to study very important gates, universal gates. So what are universal gates? NAND and NOR. So let us discuss about NAND and NOR, and also let me prove you here why NAND is called as universal gate. Means by using NAND alone we can able to construct remaining all other gates. Okay, so note down this NAND gate, which is also called as bubbled OR gate. NAND gate, which is also called as bubbled OR gate. Let's see. So this is AND, just I am giving inverter AB. So AB bar is the output. AB bar can be written as, by using Boolean algebra, AB bar can be written as A bar plus B bar. That is what bubbled OR gate. You connect bubbles, inverters to OR gate. So this is A bar plus B bar. A means up to here A bar, up to here B bar. or else just take inverters first, then connect these two inverters to OR gate. A, B, A bar, B bar, A bar plus B bar. Okay, so simply I will write the logic symbol as like this for NAND gate. AB output Y is equal to AB bar. This is the logic symbol of what? NAND gate. So note down this logic symbol, all of you. Now let's see the truth table first, then after diode model and transistor model. First let us see the truth table. So the truth table says A, B, output Y is equal to AB bar, 0, 0, 0, 1, 1, 0, 1, 1. So here you can observe for our AND gate we have the logic 0, 0, 0, 1, just inverse of this, invert this 1, 1, 1, 0. That means if any one of the input is 0, output will be 1. If all the inputs are high, output is 0. Likewise, we can able to say the various types of definitions. Okay. Now, let us draw the diode model. Diode model means just first you draw AND, then you add NOT. Then transistor model also same. How we drawn the diode model of AND? Then we are going to add NOT. So, AND means diodes are facing towards this side, right? So this is the diagram. For this you can add NOT. Okay, VCC, AB. So this is act as your diode model of AND gate. Then coming to transistor model, so just same diagram, but previously you take an output here, instead of here, now you collect the output here, A, B. Now the output is AB bar. So AND gate you take an output here, NAND gate you can take output above. So now we are going to see the very important point, that is NAND gate is act as universal gate. This is very important and interesting. NAND is act as, or NAND is as universal gate. So let us make it as why it is universal gate. To avoid the space I am not keeping heading. So A, B, what is the output? Y is equal to AB bar. By using NAND now I am preparing NOT gate. How to prepare NOT gate? So A, B, just to give the same input A. Instead of B also A into A bar, which is what? A bar. A bar means what? If A is the input, A bar is output, means inverter or NOT gate. So by using NAND, I prepared NOT gate. Next, you can see, so if AB is the input, the output is AB bar. Connect a inverter. Inverter means this is the shape. So just I connected. AB bar whole bar. AB bar whole bar means what? AB. So this is what? AND gate. So by using NAND alone, I prepared NOT AND. Okay, and also NAND. 3 gates I prepared. And next, let us move to the next gate. If A is the input, the output is A bar. If A is the input, the output is A bar. The similar way, if B is the input, the output is B bar. Okay, now I am attaching this to what is the output here. Only by alone NAND gates I am preparing the rest gates. So A bar into B bar whole bar. Apply the De Morgan's law. Into becomes plus. Bar becomes no bar. Bar becomes no bar. It is A plus B. A plus B is nothing but OR gate. Now connect a inverter. That becomes A plus B bar. A plus B bar becomes NOR gate. In the examinations, competitive examinations, he might be asking you that to construct OR gate, how many minimal number of NAND gates are required? Your answer is 3. To construct a NOR gate, how many NAND gates are required? Your answer is 4. To construct inverter, how many gates are required? 1. To construct AND gate, how many NAND gates are required? Your answer is 2. So there are two possibility of asking questions. The first possibility are how many number of gates needed, and the second possibility are he will give this circuit. He will make the inputs are A, B. He don't ask you to draw the structure. He will give the structure. Then he is asking what is the final output. So final output at the node Y1, how much? So you can able to make this analysis. Finally you have to answer this. In a similar way, let me give you two more structures. So observe here, NAND gate, so what is the output at this stage? Then after I'll add one more inverter. What is the output at Y1 and Y2? So the inputs are small a, small b. So I'll give this structure. Now I am going to prove by using NAND we can able to construct XOR and XNOR gates also. All of you please try this. All of you try this. How to do this? Again you can watch this lecture by making 1x speed or 2x speed. You can watch this lecture. If you are getting any doubts, you can mention me in comments. Again you are going to watch this lecture. Right. Very good. So let's see, AB means here the output is AB bar. So the A signal is coming here and the B value is coming here. Okay, coming to here, A into AB bar whole bar. Apply the De Morgan's law. Into becomes plus, no bar becomes bar, bar becomes normal. Now apply the distribution law. This can be A bar can be distributed to A and also A bar can be distributed to B. A plus A bar how much? 1. 1 into something. So A bar plus B is the signal appear here. And coming to this, here AB bar, here B into AB bar whole bar. That means B bar plus AB. B bar is distributing to A, B bar is distributing to B. This can be written as B bar plus A into B bar plus B. B plus B bar can be written as 1. That means A plus B bar is the signal appear here. Both are given to NAND. What is the thing appear here? You can observe here, A bar plus B into A plus B bar whole bar. Coming to here, A bar plus B. So let me write here, A bar plus B into A plus B bar whole bar because it is a NOT gate. So whole bar gets cancelled. A bar into A is 0. A bar into B bar is A bar B bar, A into B is AB, B into B bar is 0. So here we are getting XNOR gate, which is A bar B bar plus AB is known as XNOR gate. In the same manner, if I do calculation here, into becomes plus, bar becomes no bar, and plus becomes into, without bar becomes bar, no bar becomes bar, plus becomes into, bar becomes this, as per the distribution law. So if you want distribution law, watch my previous videos. Okay, here this is XOR gate. So XOR whole bar, we are getting it as XNOR here. Okay, got it? So in the examination, he might be asking you how many number of NAND gates required to obtain XOR gate. Answer is 4. How many number of NOR gates are required to obtain XNOR gate? Answer is 5. So in this way, we are going to build by using NAND alone. We are going to construct remaining all other gates. You can see here in the first slide here, I constructed this as NAND. By using NAND, I constructed NOT and NAND AND. Okay, then in the second slide, OR, NOR. In the third slide, next slide, which is XOR and XOR bar, right? So XOR here, XOR bar, which is XNOR. So by using NAND alone, I can able to construct remaining all other circuits. Hence this NAND gate is known as what? Universal circuit. Now let us discuss the next one, which is NOR gate. So generally OR plus NOT, AB, A plus B, A plus B bar. Okay, and this is also called as bubbled AND gate. Why? Because you can see here, first let me draw the diagram. AB, A bar, B bar, A bar plus B bar, which can be A plus B whole bar, can be written as A plus B whole bar, can be written as plus is written like into A bar B bar. Okay, bubbled AND gate, bubbled AND gate, right? So I drawn here OR gate, it is bubbled AND gate. So A bar into B bar. So both are matching. So bubbled AND gate, NOR gate is called as. Now instead of this, just I am giving bubbles AND gate, A, B. So A bar dot B bar, which is A plus B whole bar. Instead of this, how I am representing this as AB, A plus B whole bar. So this is the final logic symbol. Just like however we done for NAND gate, the same procedure we are doing here. Okay. Next we draw on the truth table. The truth table contains two inputs, AB, and one output, A plus B bar, 0 0 0 1 1 0 1 1. Then for AND gate, generally we got 0 1 1 1, right? So inversion 1 0 0 0. That means if any one of the input is 1, output is 0, or both inputs are 0, output is 1. In this manner, we are going to get the logic here for the truth table. Now next we drawn the symbol of diode model and transistor model, right? So the diode model, just we connected R plus naught, that means the diodes facing towards this and connecting to a transistor. Here we got the output. So this is nothing but diode model. And coming to the transistors, how we faced the transistors? Parallelly. So instead of collecting output at here, now we are collecting output here. This is the transistor model. Okay, and then we proved the NOR gate as universal circuit, right? So why the NOR gate act as universal circuit? So first let us draw the diagrams. This is AB, here the output is A plus B bar. Then just I am making two inputs. Instead of B also A plus A bar, which is nothing but A bar. Okay, A into A is A plus A is also A. Hence it is act as a NOT gate. The similar way, so this is A plus B whole bar. Apply a inverter, then you will get A plus B. Here NOR, here OR. Just like the same shapes, previously wherever you got NAND, now NOR will come, XOR, XNOR will come, OR, AND OR likewise. Now I am giving another structure. This is A, this is B. You no need to draw, just you should name what are the values. What is the output at Y1 and Y2? Try to do the analysis for these two. Try to do the analysis. So how we will do? A for A bar, B for B bar. This is A bar plus B bar whole bar, which is AB, and this is AB bar. Just here AND gate, here NAND gate. Just applying the inverter. By applying the De Morgan's law, plus becomes into. So whenever bar is there, don't write bar. Whenever no bar, we need to write bar. Bar is there, we not written the bar. In the similar way, let me give you the next structure. Try to analyze this. So AB are the inputs. Now you need to find what is Y1 and what is Y2. So you will get XOR and XNOR and XOR. So find out this, what is Y1 and what is Y2. Find out this. What is the value of Y1 and Y2? Observe here, AB, here you will get A plus B whole bar. Here the signal A, here the signal B. So here A plus B whole bar. Plus becomes into, no bar becomes bar, bar gets cancelled, A plus B. So A bar into A is 0, so here A bar B. So here it is B plus A plus B whole bar. That means B bar into A plus B. That means AB bar. So here A bar B plus A B bar. So the bar is for only B. Okay. whole bar. XR whole bar, which is A bar, B bar, previously we seen the same. So this one is inverter, that means A bar B plus A B bar, whole bar. Both will get cancelled. Here you are going to get A bar B plus A B bar, which is only XR, and here it is X NOR. Now tell me how many NOR gates required to construct X NOR gate? 4. X OR gate 5. Just quite reverse of previous. Okay, note down this. Here this is about NAND gate and NOR gates. Note down this. So the next class we will continue about special gates, which are exclusive OR gates and exclusive NOR gates. Okay, once you go through all my previous videos, okay, of digital electronics, and don't miss the sequence, all of you go through the previous videos. After completing the previous videos, then you can follow these videos, right? This series of lectures. So further you do two things. So you can follow me on Instagram for more educational updates and job related updates. So my Instagram ID is technogate_education is my Instagram ID, and also you can follow me on YouTube channel. So my YouTube channel ID is technogate_education. Also further, if you are getting any doubts in this subject, you can ask me through my WhatsApp. My WhatsApp number is 9391 202 202. If you want to access the full videos, full course, okay, in-depthly, if you want to access the full course, test series and further support, you can download our app from Google Play Store. So app names is Techno ECET for diploma, for BTech Technogate. So these two apps on Google Play Store. Okay, so all of you follow the next series of lectures. I am going to continue in the next lecture, and please kindly listen all these lectures in series manner, then you can understand betterly. Thank you.